All right, good afternoon. This is Lucio Di Jasio from Microchip Technology, and hopefully I pressed the right buttons and you guys are hearing my voice. I'm happy to be here at this webinar. Oh, good, I got a feedback. I appreciate that. So I'm monitoring your chat line here, your questions, and I'd really love and appreciate if you actually interact with me during the next hour. I'd like to have as much as possible a two-way conversation here with you guys. The title is as you've seen, rapid development with the PIC and AVR. I will not really make much of a distinction between the two in the following, and I think you know where I'm going already. Just I'm giving away perhaps too much with this title. But I'll give you anyway a bit of an agenda here, so you see what's coming to you in the next few minutes. So first we will talk about need for speed, and I see a lot of you still joining, so I'll take a little time here in this intro to give a few more of you time to register and log in. So we'll talk about need for speed, but it's a different speed that I'm going to be talking about. And then we'll talk about rapid prototyping. And that will be a distinction slightly between a rapid prototyping hardware and software and how the two things interact. And if done well, how fast we can go then. And then I will actually quickly try to move on to talking about a very specific case. We'll talk about rapid IoT development. So rapid prototyping of IoT solutions, sensors and actuators. I will use an ADR or a PIC board. I have both on my desk. And I want to actually show you live how to quickly put together a project, build the project, and then actually show you an actual sensor working and sending data straight to the Google Cloud. And then we'll be visualizing the data from the Google Cloud live. Danger, so live things typically break. So bear with me, and I promise you there'll be some fun there. In the end, I'll do a mini summary, but there is a Q&A at the end for all of you. But as I said, if you have pressing, urgent questions, I'll be trying to keep an eye on the chat line and see if you've got questions for me, and maybe I will answer them in batches. Okay, so far so good. So let's get started. Let's talk about microcontrollers. Actually, no, let's not. The typical marketing pitch here starts with things like, oh, we got high performance, we have the highest performance ever microcontroller, and then here is also simultaneously the lowest power. This is a bit trite. A lot of marketing materials being prepared to talk only about performance and power, but there are other things that are perhaps even more important and more pressing in the developer's mind. For example, I think many of you might be worrying about things like robustness. You know, you can have a very fast processor, but if it resets constantly, as soon as there's a little bit of a spike in the power supply, you might not like it. And PIC and AVRs typically are devices that can work at very low voltages, 1.8 volt or so, but at the same time they can operate at 5 volts still, like is required in many automotive applications. In general, working with the higher supply rate will give you better immunity, better margin between your signal and the noise, right? You might be worried about EMC, so emissions. You don't want to emit too much, radiate too much. You don't want to be too sensitive to radiations coming into your circuit. These are things that are actually very often much more important than the performance or the speed, as in number of millions of multiplications you can do in a second, especially when we talk about real product in embedded control. Another thing that rarely you will see discussed is, and everybody will be focusing on megahertz, is the stability of the supply. You know, many vendors make microcontrollers, and then a few years later they cancel entire families of them only to push a newer family. And in embedded control and in development, and even in the hobbyist community, instead, the persistency of the stability of the supply of microcontrollers is very important. And PICs and AVRs have been there for 20 years. And you guys know that you can order today even the very first PIC microcontroller ever in the very first series. Say you want to order a PIC 16C54, or even the very early generations AVRs are still in production and will continue to be for a long time. So stability is very, very important. Anyway, big pitches, but today I want to talk about time to market, actually, that type of speed, which is very different. And so how fast you can actually go from the drawing board to a real product that works, or from a little concept in your mind to a working little demo that you can show to your boss or to your friends. And that type of speed is what I think is very important nowadays, because we need to innovate a lot. We need to get our ideas out, and that type of speed is the most precious, because well, actually, our brain power and our time is the most precious thing. So this is the need for speed I'm talking about, and this can have variations, as in, there's a new type of microcontroller coming out, or maybe has a new fancy peripheral that you would like to try, but then, oh gosh, it takes an hour just to understand, reading the data sheet, understand how that new peripheral works. Or it's a new microcontroller, but you have to spend a day just to install compilers, IDE, and install them in the right order onto your machine. It's complicated, right? So just evaluating a microcontroller or some new features in a microcontroller can be very, very time consuming. And same thing goes for sensors and actuators. There are a lot of new smart sensors being offered today in the market that are fully integrated, they are pre-calibrated, compensated, they do really wonderful things. But oh man, learning how to use them can take still a long time, and they actually get more and more complex over time. There's some of the grind of everyday development also. There's a lot of repetitive development when you talk to always the same peripherals, but with different microcontroller families. So you know how to use the SPI port on a PIC, but then here comes a new AVR and you don't know how the SPI works on that one, and then, or you thought you remember, but that was a X mega and this one is only a mega or a tiny. So how can we speed up that? And here is where actually, if you know the PICs and the AVRs, you know that there are thousands of models. Just when this year we were trying to count them, and we figured out that we have more than 1,500 different models between the PIC and the AVR, actually well in excess of that number. And we stopped counting at some point, basically. And that's great. It's a good story. You can always find the chip that has the right flash or the right RAM, but oh boy, they're also all slightly different, and so it's time consuming, and you don't want to waste your time digging datasheets and downloading datasheets from the web. So ideally, you guys want to focus on your project. You want to work on the things that the sensors, the IoT applications that you want to develop, whatever your focus is, and you want to spend your time there. So for that reason, a few years ago, we developed in Microchip one concept. We called it the MPLAB Express. It was a combination of hardware and software. We created some easy-to-use little boards. There you see one, the green board that you see on this slide set. Some of you might have seen it. And we put there a small PIC micro. And then we actually took our existing IDE, so the development environment, which is MPLAB X normally for the PIC, and we took that and we put it in the cloud, and so that you can access basically a full development environment without installing anything on your machine. You just have to have a browser, and as long as you can type in your browser this web address here, mplabexpress.microchip.com, you instantaneously have access to the full installed IDE with all the libraries, with all the compilers that you need. Everything is there, and example projects and whatnot. So basically, at the speed of Facebook, basically connecting to your Facebook account, you can have access and try out a new microcontroller or a new peripheral. And this is great also for students and obviously for hobbyists, I think, because again, you don't have to download a gigabyte, not a megabyte. Those days are gone. You don't have to download a gigabyte of code and then spend a few hours installing that thing, and then add the compiler, download that, and include that into your installation, and do all that right. You only need to open a web browser. Okay, that was an interesting tool, MPLAB Express. It's been almost 4 years now. It has its following, but of course I cannot compare it to the other, well, the elephant in the room here, which is Arduino, right? All of you will be very familiar with Arduino, I'm pretty sure. And this has been 10 years in the making, growing and by leap and bounds, and conquering the world, basically. This is just a picture of one of the Arduinos, the Uno. There are thousands of models nowadays. And the original Arduino has always been actually an ADR only thing, but nowadays you can find in there PIC32s, MIPS processors, ARM processors, and all sorts of FPGAs. Everything is in the same format. And this tells you a lot about the need for rapid prototyping, because that was the whole idea behind Arduino. And it's been very successful, and it's shown the entire industry what the community really wanted and what was needed. And recently, actually, this is a pretty old format. The more recent evolution of Arduino has gone smaller. And I show you here an Arduino Nano, for example, same AVR, basically just different form factors, smaller USB connector, some other little smarts there. But even other vendors like Adafruit has created an entire series of products. They call them feathers. I like the name feathers, actually. They have the same different processors. They can run different code or Arduino code. So it's gone smaller. The feather form factor is kind of getting some traction. No more than 10 days ago, Arduino did another launch at the San Mateo Makers Fair. And you might have seen that they launched yet another round of Arduino Nanos. And here's just one of them. I think there were 6 models in total. This is the Every. Again, it's a Mega there, an AVR. And this is the latest and greatest Mega, the Mega Zero family. So they put there a 48 kilobytes, so they triple flash memory and triple RAM versus the original Mega. So, but they included also many of these nanos, including radios and including IoT solutions. So let's see how we can go in that direction and take in that direction the entire Microchip series. So Microchip has actually developed similar boards, small and big ones, right? So at the top, the largest one, actually I should say the longest one, it's got 48 pins. This is the ATmega 4809, so the Mega Zero series. Curiosity Nano is the name that I gave this boards. And the bottom is also Curiosity Nano, but it's for a 28-pin device, so a much smaller package, so half the number of pins. Very low-cost boards. What is interesting is that these boards are not just a surface mount chip mounted on a PCB, so that you have the equivalent of the dual inline packaging there. What is important is that they have the USB port and they have some smarts there. And the smarts include the fact that they can communicate over a serial port over USB, so basically like Arduino. So you have your good old serial port basically to do your printf. And to communicate physically wired to the board. But also they have a new thing, which is the drag and drop programming. So if you have a full hex file with the code compiled for your PIC or for your AVR, you can just connect this board to your laptop or to your PC, and your PC will think that this board is a hard drive. And so you can actually copy files or save files to this hard drive, and I should say hard drive in quotes. And as soon as you copy this file, the file is immediately programmed into the chip and the chip starts running, which means a lot of good things. It means it's going to be super fast programming. And it also means that you don't need a bootloader. In fact, this happens automatically there because of that chip that I'm pointing with the blue arrows in the slide. And that chip is called the PIC4 Nano. And that does all the magic. Does in fact a third thing as well. It also acts as a full programmer and debugger. So if you guys are PIC heads, you will call that function, you will call it the PIC3 or the PIC4 or whatever, the universal programmer for PICs. Well, it's inside that chip. And if you are an AVR freak, then that chip does the function of an ICE. So you have full programming and debugging from inside Studio if you are in the AVR, or MPLAB if you're on the PIC. And that is a lot of functionality in just that little tiny chip. So this is cool, and it's in the right form factor. We like it. It's very low cost and it's very effective. But all this now is targeting a breadboard. So you see those pins all around this board. Those are meant to be mounted with headers on a breadboard, or if you're doing something wearable, you want to wire directly to that. Right? Now, to help you even further prototyping, we created also a baseboard that is now universal, because no matter if it's a PIC or an AVR Curiosity Nano, if you plug it into this board, then you get further expansion. And so you got a few LEDs, you got a few buttons, and you see those 3 green boards that are mounted there. Let's talk about those. I bet many of you already are familiar with the clicks from Microtronica, or Micro-E, as the new name goes. Well, let's talk about those. What are those? So Micro-E, previously known as Microelectronica, they just recently rebranded themselves to a more friendly name with less Ks. So Microelectronica has been producing this little daughter boards or expansion boards or mini shields, whatever you want to call them, for 4 or 5 years now, and they have accumulated 500 plus. I literally stopped counting because every day I look, there's 10 more. 500 different of these little shields. And this means that among those 500, you have displays, you have wireless radios, you have sensors for your breath, for alcohol, for poison, for anything you can think of. You have pretty much any sensor that I've been looking for is available on one of those clickboards. And they're all nice in this standard form factor, which is quite small. And it only requires the socket. You see the socket on the left of my slide. This is the This is the microbus socket. And so we put that microbus socket on every new demo board that we developed in Microchip in the last 3 or 4 years. And of course, as I showed you before, there are 3 of those sockets on the baseboard for the Curiosity Nanos. So now you have quick exchangeable cores, so you can put a PIC or an AVR, any size, any number of pins, and you can have a quick and exchangeable any number of shields, up to 3 on that baseboard, that you can swap and try out for different actuators or for different sensors. And that, I think, is pretty cool and pretty fast as prototyping goes. Now that's hardware. How about software? How can we make software faster and more efficient? So there are 2 solutions that we have been working on, and we've been improving in generations and revision over the last 5 years. On the PIC side, we've been working on a thing called the MPLAB code configurator. But very much in parallel, on the Atmel side, on the AVR side, we were working on Start. And both of them are generators, code generators. And by code generators, I mean there are tools that can use a template, a database of templates, in fact, to help you build the skeleton of your application from scratch. And mind, this is not a tool that just takes a lot of code and just copies on your hard drive, filling up your hard drive with megabytes of source code. These tools take the templates and then they customize the templates according to your clicks and your selections on the screen. I'll show you these things practically. So it's actually, I don't want to spend too much time telling you what it is. I want to show you how it works. And as you configure, the templates generate code, and you get the minimum amount of source code required for the job. You don't get thousands of functions in a library. If you're going to use only 3 function calls, you're going to get only those 3 calls. Now, the 2 tools work slightly differently and slightly similarly. There are differences. There are pluses and minuses on both sides. Code Configurator tends to be an installed tool, where Start only works from a website. And again, I don't want to debate which one is best, because they really do incredibly smart things in both ways. What's important is that both these tools support hundreds of PICs and AVRs, and both these tools also know 100 clicks at least, and we're adding new clickboards, the microelectronica clickboards. The combination of the two means that you can really create entire projects or examples very, very fast. And I'll actually try to give you a practical demonstration of that. So now, just for the look, this is what the ADR Start looks like. So you will recognize there's like a block diagram with dependencies. You see your project in the top, and then you see the various peripherals or libraries that you might be using in a project. And then if you click on each one of these blocks, you can further configure them below. This is an online tool, so this will work inside your browser. And this is MCC. In MCC, rotate the picture if you want. At the bottom here, you have a list of all the peripherals available in a given microcontroller and all the libraries available for that microcontroller. And then you double click on one or more of them, and you add them to your project. And so up here, you have a bucket basically where the libraries and peripherals that you picked are now put together into your project. And then you select one by one these ones, and you configure them. Sometimes it's very graphical. Sometimes it's just a few checkboxes on a little text entry field. We will use this one actually, I think, in the next 10 minutes. So there is a piece of news actually. As of literally a month ago or 2, actually, that was end of February. Now the AVR is also supported in MCC. Now, AVR, MCC, 2 acronyms. So what this really means? It means that if you are an AVR freak, you're gonna have now 2 choices. You can use Studio, Atmel Studio, plus Atmel Start, or you can use MPLAB X plus MPLAB Code Configurator. So you have more options than ever. And depending on whether you're going to use only AVRs or you're going to use a bit of PICs and a bit of AVRs, you might prefer one or the other. It doesn't make a difference to me. So great news anyway. Your number of possibilities just doubled up there if you're an AVR user. Now, I'm very enthusiastic about this one, and so here I included a little self-promotion. I actually ended up writing a book a couple of years ago to show you how this works so nicely. I put 20 projects, they're very basic projects that use a variety of peripherals. Some are using I2C, some use SPI, some use displays, some use fancy sensors. You can basically develop each one of these 20 projects by never writing more than 10 lines of code, because the magic is provided by the clickboards and by MCC. So there, you can find this book on Amazon. It's called In 10 Lines of Code, and or you can buy it directly from the printer, which is lulu.com. And just look for Lucio, and there are not many others there. There's only one Lucio. Let's go practical. I want to do something hands-on with you. I want to show you something hard. I want to show you IoT done rapidly. Wow. So why is it hard? Why is it hard to do IoT and do IoT well and do it fast? It's hard because most people look at IoT, and today at least, and think that they can put everything, actually they want to squeeze everything into possibly a single chip. And the truth is that, well, first of all, there is no IoT without security, right? So we're not even going to talk about doing IoT without doing something secure. There's been way too many breaches, way too many hacks. I don't need to tell you, convince you that IoT must be built with security from day one, right? So assuming you do a secure IoT solution, and just an example here of a solution that will do Wi-Fi connectivity, for example, so a sensor that connects via Wi-Fi. If you do this, you will need some cryptography for signing and authenticating and coding your communication with the cloud. You're going to need some place where to store securely the keys that you're going to use for the signing and for your authentication process. You're going to need a TCP/IP stack. You're going to need a secure socket layer, probably a scheduler or an RTOS of sorts. You will need to talk to your Wi-Fi radio of choice. You will choose probably a module or something. And then on top of that, you will have to include an MQTT library. That's a very common, but it could be co-op. It could be, there are a few other variants there. Most IoT applications nowadays have this common layer in MQTT. Now, squeeze all of that together, and only after you've done all of that, you can start writing your application. So you're starting from 250 kilobytes of code, possibly up to a megabyte of code, depending on how big those libraries are. And then good luck. Good luck debugging a thing like this. Most purchasing managers, most project manager will tell you, poor developer, that they want everything in a single chip, possibly. But as a developer, you cringe because you know that if this is all in one system, and then maybe you want it also certified so that you can sell it in the States, or you can sell it on certain markets, or if you have a Wi-Fi connectivity, like in this case, it must be certified. Then you know that every time you're going to touch a line of that code, you're possibly infringing on your certification, right? And it's going to be a nightmare. I think this is the hardest possible way that you can think of doing IoT, and I don't want you to go down that route, because this is a very long and lengthy and treacherous path. My proposal to you is that we do things slightly differently. We apply an old tactic. We apply the divide and conquer tactic. So let's do it this way. If we separate the concerns for security and for connectivity from your application, then things get much, much simpler and much more manageable. And we can develop this much faster. So first of all, for all the connectivity, in this case, I have an example with Wi-Fi. So you want to have TCP/IP, the entire networking stack, and the secure socket layer, TLS, and the Wi-Fi radio, all managed internally by this smart module. You want to have a smart module that does all of that for you. So in this case, in the picture, I have a Wink module, the Wink 1500. It's a very inexpensive little module, pre-certified for Wi-Fi. It does all the networking for you, so you don't have to know how TCP/IP works. It just works. On the other hand, my recommendation is that you take care of all the cryptography, and there's plenty of chips out there that have some crypto. Some chips have some random number generation capabilities. Some chips have some capability to store securely keys and some not. And instead, you take all of that out and you put it into a secure element. Now, this is recommended. This is not just Lucio telling you that, but this is recommended by Anthony Passamar, by the gurus at Google, at Amazon. They will tell you that if you want to do secure IoT, use this chip, use a secure element, and the ECC 608 is the latest and greatest. So what it does is that it looks like a small E2 PROM for you, but what it does is it is designed to store the keys securely. So please don't put your keys for your crypto inside the flash of your microcontroller. Please don't do that. And it also does all the authentication algorithms and all the cryptography all the way to elliptic curve with 256 points, the highest level of security. What you guys use when you connect to your home banking account. That's the level of security this chip will give you. And it takes care of all that automatically in a very low power little chip that looks like a serial E2. It's got only 8 pins. And then in the center of your application, that's where you have just a normal PIC or an AVR, a microcontroller. You can focus your time and your effort on that chip. And that's going to be a much smaller effort and it's going to take much less time to develop, especially because if you use Start and MCC, even the MQTT part of the equation, even putting it all together and connecting the sensors, all of that will also be taken care of by the code generator. So there was a long intro, but now I'll show you practically how this is done in hardware, in a real design, in a real cost-effective, simple, very easy to use, rapid development design. So this is a board that we developed with Google, together with the IoT core team in Google. And we developed with them, but to really exemplify this philosophy. So you see on the right side, that's the WINC, that's the network controller. Right? So it's a Wi-Fi radio, but it also has already all the TCP/IP connectivity. On the left side, you see the little element, a black little chip that is pointed by the red arrow. That is the secure element. And the secure element is actually the smallest chip on this board, in fact. And in the center, what you see there, that's the Arduino, latest Arduino Nano, same identical chip. This is the Mega 4808. Latest and greatest chip, this is the 32-pin version, basically. And 48K flash, 6K RAM, etc. 20 megabit, 20 MIPS, blah, 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 blah. All beautiful core-independent peripherals of the latest generation. Plenty of good things I could tell you about the chip, but I'm not going to talk about it. What I'm talking about is that putting together these three things, now you can focus only on writing your AVR code, or the same board with a PIC instead. This is actually a picture, and the previous one was more a drawing. The same board exists in two flavors. This one has a PIC, and this one has an AVR. But they are identical in all other respects. And what else did we put on this board to make your experience, your IoT prototyping fast? We actually added this portion on the left of the screen. Hopefully you can see my mouse, where the USB connector is. And guess what? This chip here is the same chip that we put on the Curiosity Nano boards before. This is the PIC-UP4 Nano, which means that it acts as a serial to USB port. So your AVR can talk directly to USB without any additional code. You just talk to it via UART. It also acts as drag and drop, and I'll show you live how that works, how nice it is. And so this entire board, when you power it up and you connect it to your laptop, looks like a hard drive. Your laptop thinks it's a hard drive, and you can drag and drop new files to it and run them immediately. And then, but this is also full programmer debugger. So if you have Studio, Atmel Studio running on your laptop and you connect this board, or if you have MPLAB X, now I told you, AVR is also supported in MPLAB X, this board gets immediately recognized as if this was an ICE. We added a few other extra cool things. We added a battery charger because we thought this could be a very nice little IoT node. So let's put a battery charger so you can attach here a nice LiPo battery, a 3.7 volt LiPo battery. And here also we added a DC-DC converter, so you have the maximum efficiency in transferring this 3.7 volts to the 3.2 volts that you need for the microcontroller and the logic here, the radio mostly. And you don't waste any power there. So this is a very efficient DC-DC converter, as you can see, fully integrated. We put also a couple of sensors on the board so you can play immediately and get something going. And you'll see that in a second in action. One is a light sensor, so I have a good excuse to show you something that changes quickly under your eyes. And then we put a high precision temperature sensor here, just so we can claim it's a serious sensor. And it's actually a precise temperature sensor that is going to measure how the radio module is affecting the temperature of the board, and we can monitor the equipment with great accuracy. It's a 1/4 of 1 degree precision temperature sensor, very high precision temp, pre-calibrated and all. Here you recognize the micro bus connector. So here is where you can plug in the clickboards. So here you can attach 500 different sensors or displays or actuators or relays or whatever you want. So I showed you, this is the picture, the same board, but with a PIC. And guess what? Every other component is identical, and just the code is written in C. So it will actually be 90% identical even in the source code. But so how is the code generated? And how and what we're trying to achieve with these two little boards. So as I said, first of all, we wanted this board to be something that allows you to focus on the sensor and not focusing on the security or on the networking, right? So with this board, it's very easy. If you have an algorithm that is running on your Arduino or that is running on your AVR or your PIC, and that reads the sensors or controls some mechatronics, well, it's going to be a minute to transform that into something that connects to Google Cloud, for example. It's going to be really a snap. As I said, you don't need to become a networking guru. I mean, connecting to Google Cloud can be complicated. If you are not already a networking guru, you will appreciate the time saving here, which is massive. And at the same time, no compromises on security. Because we use the secure element, you don't need to become an expert in cryptography. You know that this will enable your board to connect to the Google Cloud with the highest level of security that the Google Cloud allows, which is elliptic curve 256 point SISMA. Now, so the idea is how, with this board, we really show you practically how we won on the complexity of IoT by simply doing the splitting of these responsibilities between the three modules. And of course, it's a PIC or it's an ADR, so it's very robust, and it can be very, very low power. You get sub 100 nanoampere power consumption when this thing is in sleep. And plug and play rapid development. Let's see how that works. So I will try now. I have a few minutes to go before the Q&A. And I want to actually try live to show you how all this can actually work. So hopefully and bravely, you will see my desktop now. And I'm gonna connect the USB cable to my laptop. You see I'm using a Mac, by the way. So MPLAB X works on the Mac. So if you're an AVR freak, you will also appreciate how you can develop for the AVR on a Mac. So there you go. So here you see on my desktop just appeared something. You see that thing called Curiosity? That's a hard drive, right? Well, that really is the board that you saw before. And so hopefully you are curious people, and you will try to open it. And inside that board, inside that hard drive, which is really, there's no storage, it's not a hard drive, it's just all it pretends. There are 5 pseudo files, and one of them has an interesting name. I'm not going to debate what the others are doing. They're all useful for some reason. But click me, I'm curious. I want to click on the click me and see what happens when you click on the click me file. You go to a website, depending on which board you're using. Actually, this could be, the website is going to be ADR IoT or is going to be PIC IoT. And I didn't do anything else by that, simply clicking on it. What you see is that that automatically opened the default browser, which on my laptop happens to be Chrome. But this works also with Safari, works with all the other browsers that we've been throwing this at, except some really old Internet Explorers. So hopefully you're not using those. And as you can see, there's data here, and there are 2 graphs that are moving in real time, and they're showing something. Well, this something that you're looking at, this is the serial number of the board that I connected here. And you see, the trick was that we passed that serial number in the URL. You see it up here, right? It matches this number. So that's how my browser knew how to go inside the Google Cloud and how to fetch the data that is coming uniquely from the board that I have here on my desk. You want to see that this is really my board, and we want to see also how fast is the reaction. Imagine this data has to go all the way to the Google Cloud servers, which we selected California. So this is on the Pacific coast. See, I'm putting my hand on top of the board, and now I'm removing my hand from the board. You'll notice the light sensor just went down and up again. I'm going to do it again now, and I'm going to remove my hand now. It's a 1 second delay time or less. It's really fast, really responsive. And you also see here the temperature, and the temperature is steadily going up. Don't worry, there's no 29 degrees in my room. This is the temperature of the board And in particular, this is the temperature of the WINC, the radio, the Wi-Fi radio, which is transmitting a full blast, full power samples every second, and is maintaining a constant connection. So this will go up to 31 or so, and will stabilize that. So it's not the ambient temperature. This is measuring equipment temperature. Okay. So very, very much real time. Okay, cool. You will say, can I also talk to the board and send commands to the board? Yes, of course you can. Just scroll down, and you can now send commands to the board. You can send a toggle which will turn on and off the yellow LED on the board, on, and it will go off now. But I can also add and send messages, text messages to the board, or I can add a slider and then send a slider position to the board. And I can have as many sliders and as many text or toggle inputs as you want for prototyping, for quickly testing how effective it is to send or receive commands to the cloud. Okay, I'm feeling quite happy with this demo. Everything has been working nice, so I'm going to try to look for more trouble, and I want to show you live how actually I can develop the same application that you've been running there by launching MPLAB and creating the project in 2 minutes in front of your eyes. That's pretty bold. Let's see, this is MPLAB 520, the latest version I have here on my laptop. And as you can see, as soon as I powered it up, it recognized that the AVR IoT board is connected. And so it says, hey, this is your programmer debugger as well. I'm ready to use it. So I'm going to generate a new project from scratch in front of your eyes, okay? Hopefully you can follow me fast enough. It's going to be just a standalone project. I'm going to do it for the 4808. The Mega 4808. You see, MPLAB knows the AVR. So, and I tell him, yep, use the board that is connected as your programmer debugger. I use the AVR compiler. I have a few choices to use more compilers. And I'm going to create this project, which is going to be called Live. And I'm going to do, and voila, we have a beautiful empty project in front of our eyes doing absolutely nothing. It contains absolutely nothing, nothing in my source files. I'm supposed now to crack open the datasheet and start working for the next couple of days until I can get the demo ready for you. Or I can actually activate the code configurator, which is this beautiful little shield up there, the little button that you see there. So that's what I'm doing. I will create a new configuration for it. And as you can see here, as I showed you before, I have a selection of all the peripherals inside the AVR, and then I have all the clickboards, and then I have a few example projects. I'm going to tell him that I want to create an IoT project, a sensor node in IoT. So I'm double clicking on this one. And now you will see that we have brought a whole lot of peripherals have been pre-selected and put together in this project for me, because he knows that to do an IoT sensor node, I need a UART, I need the A to D converter, I need the SPI to talk to the WINC, and I need the I2C to talk to the secure element. So in here, I can configure my MQTT broker. In here, I can decide what is the Wi-Fi, what are the Wi-Fi credentials on my local router here. You can customize those. Or I can even change basic settings of the project, like how often the sensor will be read. And once I'm happy with these settings, there's a whole ton of them that you can go and customize now. You can change the pinouts. You have a nice grid here to configure your pins. But I'll take the defaults for now because I want to do it really fast now. And so I'll go here and press this button. It's been a bit compressed now. It says generate. And I'm generating the project right there from the templates, and with the configuration settings, I built my project. Now you'll notice here there is a whole bunch of files and libraries that have been customized for the use. Well, they are ready to go, so let's give it a kick. I'll do the build, And as you can see, the compiler starts cranking out, and the build is successful in 3 seconds. And I'm ready to run. This is a full project, a full IoT application that is ready to run on our little board. I want to try it out again, and you will see it here transmitting data to the Google Cloud in 1, 2, 3, 4, 5 seconds or so. And there you go. Light and temperature scrolling on your screen. Did it take me more than 2 minutes as I promised you? I think it might have been 3 minutes. I'm looking at the clock right now. Okay, seriously, I want to see some questions, guys. I don't see anything yet there, and I think you should be at least confused, perhaps pleasantly confused at this point. But this was fast. I hope you will agree. I can anticipate some questions if you're feeling shy today. And I have some easy ones for you. So how about Amazon? This was going to the Google Cloud. Can we do Amazon with these boards? Let me see. Do I have the questions open? Let me see. All right. Oh, here I'm scrolling. Sorry, I was not scrolling the list. I was always looking at the same question. So what language do we use for coding? Yes, the code generators are generating C code, and you have full access. You can see every single line of code. There is no it's all Apache 2 licensed, by the way, so you can modify and update any way you see. You're saying awesome. Yes, I agree. This is awesome. I'm kind of confused. Great. Okay, there is one confused among you. That's a good start. Are there any costs to use the Google Cloud? Yes, the Google Cloud starts, if you use this board as it is here, it's free. It's a 100% free. We have a sandbox set up together with Google. We agreed that you're not going to pay anything. In fact, it's totally anonymous. I don't know if you noticed, but I did not enter any password or any login at all, because we created a sandbox for you. And these boards, as you buy them and then you connect them to the cloud, just go straight to the sandbox. Now, when you want to go to your own private account, then you must have a private account. So you need to actually give your credentials to Google, and they give you the first $300 for free, basically, which is a ton of megabytes. I don't know how many gigabytes actually of data that is. So before you get to consume your $300 quota, it's going to be a while. But again, the appetite comes as you eat. There are a lot of services inside the Google Cloud, so this data goes in there, but then it's up to you to actually start using it to do cool things. So if you want to attach auto ML, machine learning, on your data to learn things, or I don't know, it's up to you. You're going to start using machine learning services, you're going to start using database services, and then really you can start slowly adding cost to the application. But yeah, nothing dramatic. All this, you have to think that all these cloud services are meant for gigabytes or hundreds of gigabytes of data, and especially if you're a hobbyist, this are your usage of the services is going to be negligible compared to those. Are you connecting the board directly to your laptop? Yes. So I am at the moment, as you've seen, I connected the board directly to your laptop. But once you connect the battery and the battery is charged, then you can disconnect and you'll see the same data. Actually, let me do that. I'm going to connect the battery. And so the battery is connected. I'm going to show you that I'm going to take the connection out. So hopefully you've seen that I've disconnected the USB cable, but the data is still coming. So the connection is really, it's all the way to the Google Cloud, and then my browser all the way from the Google Cloud fetching the data and displaying it back on my laptop. Great questions. I already used the Google Cloud. So what to do in Google Cloud to set this up? Simple. You create, you enable your IoT core service, and then you create a registry, and then you go to the to the device, and you ask for the public key from your device, and you add it to your registry. How do you ask for the public key? As I showed you, the hard drive, you open it, the public key is this file. Copy that file into your registry, and voila, your board is now inside your existing Google Cloud account, and you can start playing with it immediately. No, you don't need programmers. As I said, to burn the solution into the board, everything is already on the board. You only need a USB cable. Fantastic questions, guys. Keep going. WPA, can it support enterprise hardware certificate? Well, so it does suppose the Wi-Fi module supports enterprise mode, but you will have to program the certificate, the X209 certificate, 509 certificate in the ADR and then pass it on to the Wing. So out of the box, we are not doing that. Well, that's a hack that I would like you guys to do. Take the board and add that support. We are supporting just WPA to PSK and open and the old web mode for now. It was effectively fast. Yes, it is fast. Oh, you want to know how fast is the AVR going on this board? You would think this is a 20 megahertz AVR, and you know what? It's running at 10 at the moment. It's really not a problem. Once all the crypto is done by the little secure element, it's a piece of cake. We can actually go slower. We just have not tried to see how slow we can go. What is the cost of the board? We're selling it, I think it's $29 or 25 euros, I think. You can just check directly on Mouser. This is the ADR IoT board or the PIC IoT board. And Mouser has both in stock, so you will see it's quite inexpensive. Yes, that was fast. I suppose they are referring to the 2 minutes build your project demo. Okay, I have one more question. Okay, there's one more thing I want to show you. We are in the last 5 minutes probably of the event, and it is that I lost my track now while I was looking at this. Yeah, if you scroll down further, you'll see more details about the modules. Ah, yes. This is what I wanted to show you guys. In MPLAB, I did show you that all the code is written in C, right? Okay, well, guess what? If you want to add a sensor, or if you want to add an actuator and you want to send or receive data from the cloud, how do you have to modify this project? Because as you can see here on my screen, we generated a lot of files, and this can be confusing, you know. Oof, which one of these folders do I have to go and hack into to add something special for my board? Well, you will see that here in this file called sensor handling is where we put the actual reading of the light sensor and the temperature sensor. I think that's intuitive enough. But then if you want to do any of your own hacks, really, there's only one file that you have to go and look, and it's main.c. And in main.c, you will pleased to see that there are two very simple functions. One is called receive from cloud. This function is called every time the cloud is sending us something to do, a new configuration, something, a message, a toggle command or something. Well, once that happens, we just, this function is being called. So here is where we decided, for example, that if we receive the word toggle, we're gonna turn on the yellow LED. Now you can change it to do something else, like turn on a relay, for example, right? And here in the send to cloud, this function is called once a second. Well, in the present configuration, you can change the interval to be anything you want. Faster than a second, sure, you cannot go too fast, obviously, but for IoT applications, actually, this number could go from 10 times a second, say, to, I don't know, once an hour, once a day. It's up to you. Well, whatever this parameter is, where you configure the project at the very beginning, this function called send to cloud will be called once every send interval. And so all you have to do, for example, you see here, this is where we send the light information and the temperature information. You want to send more data, you want to send another sensor data, a third, a fourth, a fifth, and 101, just add more to this sprintf here. So literally sending data to the cloud is very close to doing a printf to a serial port if you want. it just all then happens magically here in this cloud publish data function, which is equivalent to say a printf, really, to the cloud. Of course, there is much more detail. I'm oversimplifying quite a bit, but if you want to go to a second layer of hacking after you played enough with these two functions, and this is the entire main file, by the way, see how simple it is? It fits in one screenshot. I like short files. Once you want to go and hack deeper, then you start just command click on this name, and you will find that cloud publish data is really this function here, and then you go and define it and find it in your project and drill in and go as deep as you see fit. See if we have more questions while I was chatting my way away. Narrowband, oh yes. People asking about narrowband and other radios. So, okay, last 5 minutes, let me get back to you guys. We need to talk about narrowband. Is there any way to save the data from the board? Yes, you can just go into your own account, and when you receive the data, you pass it on to one of the 6 or 7 different database types that you can control from Google Cloud, for example. And I mean not encrypted output. Yes, so all the communication to the cloud is encrypted pretty heavily, and the board is authenticated so that only good data from your good boards goes into your account, right? But what you see inside this two function here is not encrypted. All the encryption happens magically for you. That's what the WINC does. That's the network controller module power together with the secure element. So here you see strings in clear, but over the radio, over Wi-Fi, and through the internet, all of this is seriously encrypted, pretty hard. Okay, so we are at the very end here, and I think I need to just give you the final slides, and it's time to say goodbye already. So obviously this was an example with the Wi-Fi, but we have boards with Bluetooth that are based on the same form factor, and that we're going to be launching this summer. And of course, we also have already done demonstrations with the new LoRa chips, the SAM R34 system in a package, and we have modules from Mbit that are already using that chip that can work very well with this solution. So we are preparing a number of options for wireless connectivity. Narrowband is in design. We're looking at the vendors. Obviously, the big question mark is now with 5G and which one of the competing narrowband technologies to choose. So narrowband will be something for the later in the year, toward the end of the year, possibly in 2020, I think, as we see the 5G play out. Needed to mention very quickly that there is it's very easy to connect these boards to a voice control system. So you can have, when you connect to Amazon, you can use the Echo to talk to the boards or to ask the boards to do things for you. And the same thing if you have, obviously, the default account from the Google Mini, either using the app or from the Google Home devices, you can actually give controls, give commands to the board and receive, ask for queries and status information and whatever. So at Masters in Arizona and later in Berlin this year in Europe, we will be actually doing a live demo and a class teaching people how to do voice control using these boards, both the PIC and the AVR. So in summary, just wanted to tell you guys, plenty of options for PIC and AVR, whether you prefer the platform MPLAB X or the Studio platform, the traditional platform. Curiosity Nano boards are the new form factor, the cool new form factor for rapid prototyping. Micro eClicks are a great solution to add a ton of rapid prototypes for hundreds of sensors and actuators. And with the code generators, whether you choose to use Code Configurator or Start, you can generate the code for those clickboards and also for IoT, as hopefully I've been able to show you today. And that was it in record time at 5 o'clock. Let's see if I missed anything big here. Cloud Publish IoT includes encryption. Yes, the encryption happens inside a function automatically. That was a great question. And is shipping worldwide? Yes, we ship wherever Mouser ships, we ship, and it's all the global distributors also. The traditional distributors are also available with plenty of these boards in stock. And I think at this, my time is up, and I hope to talk to you again soon, maybe with some updates, as soon as I get an opportunity again to be in front of you all. And I really appreciated this fun time with you today. Thanks all.